So today we're going to speak about the architecture for the AppBundles. And how I like to start my presentations is to start by variations of the topic that will explain what we will be actually talking about. Okay? So this topic is actually going to talk more about the architecture for the dynamic feature modules. So one aspect of the whole AppBundles ecosystem that you can use and that's available for you as a developer. And I will talk you through what were basically our feelings about the dynamic feature modules, how they will impact the existing architecture of our current app we are working on, and whether my team will need to spend like 2 years refactoring the code just because Google announced something new, and maybe we'll start, for example, enforcing it. So, architecture for the AppBundles. I'm Mateusz. I work as the Android tech lead in Krakow at a company named IG. So that's the UK company that does Forex, commodity synthesis, lots of trading stuff, also cryptocurrencies, in case you are interested. I'm also co-organizing the GDG Krakow meetup, and in 2014 it was Krakow to organize the DevFest, so it's pretty impressive to see how everything is working here. It definitely wasn't working like that at the time when we were organizing it. And I'm also the member of the Google Developer Expert Program on Android. So let me start with a little bit of a story, a little bit of a context for the whole of the discussion. So our developer life up until January 2018. Yeah. So what's so special about the January 2018? I'll tell you on the next slide. So we had before then we had the app module for the Android stuff. Yeah. So we had like a multi-modular architecture that was structured by different layers of tech. Yeah. So we had the app module that was keeping all this stuff related to views, activities, and fragments. Then we had the core module that was keeping all the business logic we had in there. And we had the data module that was keeping the Jackson stuff, the annotations, the retrofit gateways, and so on and so on. Yeah, so that might ring a bell. Is anybody having like a similar structure in their project? So we have like alright, one person. It's kind of popular within the Android world. There are like multiple projects that are using it. By using it, you have a couple of benefits. For example, the business logic can be like a pure Java/Kotlin module, so we are not polluting it with the let's say Android boilerplate. Yeah. So, but what are the problems with it? What were our problems? If you are working with a similar structure, it might happen that those problems don't apply to you. But they definitely did apply for us. So lots of useless interfaces just map stuff from one module to the other. Yeah, so the structure of the dependencies was that the app module was depending on the data module, and on the core module it was basically combining all the stuff together. Core module was depending on nothing but its own dependencies, but it was kind of agnostic from all the other things that were within the app. And data module was depending on the core module. Yeah, so the data module kind of depended on the core module in order to make it possible to do the mappings and so on. And since it's not like those modules knew about each other, like each of those modules didn't know about all of the other modules, sometimes you had to do the mappings of the data structures and so on. Yeah, so typical problem was you need to go to the retrofit gateway, you call this retrofit gateway, you get some data from the server, you map it using JSON/Jackson to the data structure that was defined within the business logic. You do something silly within the business logic layer, and in the end you put it on the recycler view. Yeah? So 99% of the use cases for the Android app. So a couple of the interfaces, a couple of mappers map everything together, and there were lots of classes for the simple tasks. That's just a joke, but it's kind of a well abstract in the clean code. Mappers everywhere, and even the simplest change. So let's say you need to add a new list. Required us to change all the modules. Yeah, you had to do the change to the data module, you had to do the change to the core module, and you had to do the change to the app module. So the single feature was spread across the entire code base. And this has some issues that are coming with it. Yeah? So this application is actually almost 10 years old. As you can imagine, it has quite a significant amount of the code, which was around 1 million lines. So when you are doing even the simple stuff, lots of things had to recompile. And even the incremental build times were taking a lot. The instant run helped a bit, but it was still quite a problematic in case you were changing anything to the Dagger setup and so on. So stuff became unbearable. So January 2018, which we are going to celebrate each year now, there's a new project for a new market. So we are kind of shipping the trading app to the US market, and we need to build a new app. Yeah. So we decide, all right, let's rethink all the issues that we have with within the R architecture, and let's try to restructure it in a way that it will address those issues. Okay. So we identified the core distinct functionalities of our app, which were onboarding, stuff like create the account, stuff like upload your ID. It's like a trading financial institution, so you need to upload your ID in order to be able to trade. Session to handle login and authentication stuff. Markets, all those kinds of the instruments you have on the trading, like Bitcoin, Euro USD, Apple, Amazon. So it's listed somewhere, you can search through them. So all this stuff was there within the markets module. Payments, in order to trade, you need to top up your account with the money. And finally, dealing, like the core of the app. Yeah. So all of those features exist in order to enable you to go there, spend your money, and potentially win some money too. Then, on the top of all those modules, we created the app module. We were gluing everything together, and the base module, which was kind of containing only the utilities. So those modules were tiny. Okay. The modules here were fully blown Android libraries. So from this perspective, it is a block that on one layer contains activities, views, and so on, and then contains the business logic separated, but from the app perspective, it just wires the onboarding dependency. Okay? So there is some internal app core data structure in here, however, is not exposed externally. Few decisions that we made. Feature modules don't depend on each other. URL and business logic are split within the modules. App depends on all the feature modules, and all the feature modules depend on base, which means that base needs to be kind of agnostic, feature agnostic. Yeah, it doesn't have any business logic, it just has the utilities like show fancy dialog kind of stuff. So let's see some code, like how this all works. So navigation, modules had to navigate via each other. Yeah, so user sees a market list, tapping on the market item moves you to the dealing screen, which already belongs to the dealing module. So just to visualize that a bit for you. So this is how it looks. Yeah, so this is our list of markets. The list of markets comes from base here, from the markets module. You tap, and you have a dealing module in here. Yeah, so you need to do somehow this navigation. As I said, those modules don't depend on each other, so you need to come up with something fancy in order to start one activity from another. I mean, extract the interface, just again. So the way how it works is within the markets module we define the markets navigator, which gets all the stuff it needs in order to start a new activity. And then within the app module, which has the knowledge about all the modules, we define the implementation. Yeah. So it's the application that drives the navigation between the modules. Modules themselves know that I can navigate somewhere, but they don't know how to do that exactly. It's application doing this mapping. Then we bind this. The markets navigator from the markets module is bound to this app navigator. Okay. So this is basically it. Looks like it's a little bit boilerplate, but those cross modules actions aren't that common. We literally have like a 10 methods in there that are just starting the intent, and that's it. Decorators. So this is another concept that we did. sometimes to display things from different modules on a single activity. Yeah, we have this activity in here, and take a look. List of markets is coming from the markets module. This balance bar comes from the accounts module. If you tap on the trades tab, it kind of swipes to the fragment here, to the dealing module. And yeah, and this little yellow thingy there that lets you pick your marketing preferences is onboarding module. Yeah, everything on a single activity. Modules don't depend on each other. So how this is done? So we have this decorator command concept. This is a navigation drawer example. So it's defined within the app module again. The interface for the decorator command is based, so every module has an access to it. Then you have some kind of the aggregate that aggregates all those decorator commands that you have within the app. Again, activity decorator is in the base module. And yeah, application decides which decorator commands to use. Yeah, so the code looks like this for a single one. So each activity, when it starts, it invokes this method on the decorator command that adds and receives the reference to the activity that can attach itself somewhere to the screen without this screen knowing about it. Okay, that's more or less clear? You still there? Yeah. All right. So app decides which decorator commands to use. Some decorators make use from the contract. So we agree with our designers, okay, so this is our screen, and those are the common shared parts of all our screens. We have a toolbar on the top. For the top level screens, we have a bottom bar at the bottom. Under the toolbar, there is a space for something you can attach, something small. And above the bottom bar, there is another space you can attach something. Yeah, so we had the Android resource IDs within the base module that identify those areas of the screen, so then those decorators can leverage from them. Yeah. So in the case of this yellow bar, the decorator command assumes that this activity has something like a top bar, which then it can use to attach its own view or fragment or whatever you wish. And guess what? We are pretty happy about this. Yeah. There were some drawbacks. We made some mistakes. Some of them we are still figuring out how to fix. But in general, this is a huge progress compared to what we used to have. And then I go to the Google I/O and there is this AppBundles stuff. Yeah. So and there is the AppBundles presentation, and they show me this. So I have a base app, which is basically my base application that users will download from the Google Play at the start. And there is this dynamic feature module 1, dynamic feature module 2, dynamic feature module 3 that are built on the top of this app module and are kind of providing some functionalities to the user in the modular manner. Yeah. So, and there will be dynamically downloaded as the user downloads your app. Okay. Apart from this, there is also this thing like a dynamic delivery, which is pretty nice. Because when you are having a device with a screen that is XX HDPI, then you probably don't need all those icons for a different kind of a screen densities. Same sometimes goes for the languages, but there are some exceptions, and for the native libraries as well. So effectively, if you go to the Google Play right now and go to the release panel, Google already promotes this thingy of the dynamic delivery and tells you, hey, you will save 30% of the app size download just by adding some stuff to the build Gradle. Yeah, we'll talk about that. We'll talk about that in a second. So when I've seen this, given that we are already a couple of months deep into the architecture I just detailed to you, my first impression was, nice. We did a nice investment with the modular architecture, and now we're gonna benefit it. Now Google said modular architecture is the future. So we'll just leverage from the fact that we did it like a couple of months before. Second impression, oh wow, actually not. Actually, the idea is the same, but the implementation is completely different. So, small recap on the things that you will find or you already found in the documentation. I don't want to talk about that much. So, Dynamic feature modules mean that you can install features on demand instead of building everything with it into your base app. Yeah, so imagine you have a functionality that only a small portion of users is using. I don't know, like our example, uploading this ID document, okay? Most of the users that download the app can be, for example, auto-verified using some kind of a governance system that we are connected to or something. Yeah, let's pretend we can do that. Or most of the users that don't know the app did this activation on the web already, because this is the conversion app, the conversion path that your users follow. This means that probably only 5% of the users will need it, and they will need it only for like 1 day. They will just upload the doc and they will never come back to the screen. There is no point of making all your users download this functionality because they will not need it. It's just wasting space on their phone. Then Android/Google Play does not provide any kind of the UI overlay when the application is being installed. When the dynamic feature module is being installed. So when you decide to install some certain dynamic feature module, you just you just speak to the library, which is called like a play core library. You tell them, hey, I want to install the feature that's named like this. The streaks are identifiers and the names of the dynamic feature modules, and then you just get the callback. But you can drive the experience on how it looks like. So if you, for example, display some list that will be dynamically downloaded, you can craft your UX and the UI experience in a way that from the user perspective, they will not even see that something dynamically is being downloaded from the Google Play. Okay? You can just show the same spinner as you would show anyways when showing the network request. So user would just have the impression that something is going on. It's just the kind of a loading the list. It just takes slightly longer than usual for the first time. Google Play app signing needs to be enabled in order to make it work. Who uses Google Play app signing already? Alright, everyone should be using it. Everyone should be using it. Why? First of all, in order to make that to work, because as you can imagine, all this stuff, splitting your application into the multiple files, dynamic feature modules, dynamic class loading, and so on, this is changing the signature of your app because it's changing the binary code. So Google needs to have an access to your certificate in order to perform those changes. Yeah? Now when you enable the Google app signing, you will have two keys. So one certificate that you upload or you can generate it, and the other one that Google generates for you, and it's the upload certificate, which you can invalidate anytime you want. Okay? So before this was available to developers, most of the apps just kept the key store within the repository itself and passwords within the build Gradle, meaning that any developer that was ever working on your company can potentially connect the pen drive, get the key store, and you are screwed. Because they can now basically sign your application and distribute it like using a different channel and even force the upgrades and so on. So app signing is safe. Giving your certificate to Google doesn't hurt. And then you will have the upload key, which will be only valid in case it's valid in the console, and you can invalidate it anytime. Dynamic installation and dynamic feature modules unfortunately cannot be tested locally. If you want to test them, you need to have a Google Play developer account, you need to do the test channel, and then you can test that via the test channel. Okay, so that's a big disadvantage, because if you want to test those features, then it's a little bit problematic. AppBundles themselves can be tested. You can do this kind of a structure with those dynamic feature modules even and see if they work. Disable some of them, enable some of them, but you cannot install them. In order to install them and test the installation experience, you will need to have a Google Play developer account. Still in beta, okay? Don't use dynamic feature modules on production just yet. There is no limit specified on the size of your dynamic feature modules. However, if download size is too big, and too big is not specified either, user might be asked for a confirmation. Okay, so if they're on the data plan and you want to download dynamic feature modules that weighs like a 200 megabytes, then probably user should have a choice where it goes. Okay, so this structure here. And as I said, the AppBundles come with those two key components: dynamic delivery and dynamic feature modules. Yeah, those are both visible on this graph. So for dynamic delivery, you will read all this in the documentation, so I will just quickly tell how to do this. When you build Gradle, you are doing this bundle block here, and you are saying, I don't want to split by language, I want all the languages to be included in my base APK whenever somebody downloads my app. It's pretty useful in case you allow users to change the language of the app in runtime. Density, well, this density of the screen will not change. So it's pretty safe to set it to true, unless there is this Google ARA device again, and they can switch the screen in any time. That will be the problem, but for now today it's safe to split it. And for the native libraries as well. Yeah, processor will not change. If your processor is ARM, it's gonna be ARM on this device. You don't have to download all those heavy native libraries for the x86. In case users will not need them anyways. Have you been doing like multi-listings, or like have you been like maintaining in the past the APK files that one the APK file had the x86 and the other one had ARM, and you were uploading them to the Google Play? Have you got some experience with that? Yeah. Okay. So we've been doing this once at my previous company, because one of the libraries that we used for voice over the IP was actually pretty heavy. It was like 3.5 megs, and we had to do it for ARM, for x86. We were also doing it for MIPS. I don't know why, but we were doing it. And at the beginning, all those will bundle together, and then we split it manually, because you could do it for some time already. But then you need to maintain those version codes yourself. You need to come up with something smart. So those version codes for different variants of your app are different, because you cannot upload the app to the Google Play with the same package name and the same version code twice. Now, since it's basically Google Play managing all this stuff with delivering only the libraries and densities, resources that your user may need, you just don't care. You just use the version code as you are using them for the regular apps. It's pretty cool. Easy. You should use it. This is actually not in beta. This is actually something you can use in production already. And Google Play is encouraging you to do so. Dynamic feature modules are in beta, and dynamic feature modules is something that if you want to use them in production, you need to sign up to the beta channel. So apart from creating this internal test channel, you also need to ask Google, hey, I want to give it a shot. And then you might get enabled or not. So on the dynamic feature modules, some blog posts claim that they are like the Android libraries. Yeah. But they are not. Our modules are like the Android libraries. Dynamic feature modules have a pretty fundamental difference in the way they work. So dynamic feature modules depend on your app rather than app depends on the library. Yeah. In other words, the application itself cannot access any classes that are defined within the dynamic feature modules. I mean, it cannot access them explicitly, because the code wouldn't compile. The dependency structure is kind of a reversed compared to what I shown you there. So that might be a problem, yeah? But if you think about it, it makes lots of sense, yeah? So you are downloading the base APK, and then you are downloading like the pieces that are being added to this base APK, yeah? So they are added to the top. They are not added somewhere in the middle, yeah? So base needs to be able to work without those dependencies, so it cannot work, so it cannot know about them. So the thing is that
all the stuff and all the discussion I had in my mind about, alright, should we now migrate our structure? Is it like all wrong? Because the dynamic feature modules are meant to be used differently. And the dependency structure and dependency tree has to be different. The answer is not really. Actually, you don't really have to change the architecture of your entire app in order to start benefiting from those dynamic feature modules. So I looked through the purposes of why we done our approach with the modular architecture in the way we done it. Yeah, we want to have a good separation, lack of coupling between features. This is why those features don't depend on each other. And we want this lack of dependencies, lack of coupling, and forcing the compile time. Okay, and obviously we want to have faster builds as well. Versus the purpose of the dynamic feature modules is the smaller APK size. This is the reason they are there. Yeah? And good separation is coming more as a side effect rather than the purpose here. So the purposes of our architecture is different than the purposes of dynamic feature modules. But we can combine them together. So this is our structure, and using the dynamic feature modules naming convention, this whole bit is our base APK. This whole bit is something that our users will download from the Google Play when they press install. Then, nothing stops you from building the dynamic feature modules on the top of this. Okay? So if you feel that those features are core features of your app that your user will not survive without, it's fine to have them here still. And then some certain individual functionalities that you think your users will usually don't need, however some of the users will find them crucial. You add it on top of the entire structure. So, the dependency stuff, okay? Your application doesn't know about the classes from the dynamic feature module. How to work with that. Let's say you want to start the activity, or you want to do whatever. Yeah, attach the view, attach the fragment, start a service. How to do this? Then I will tell you how to do the dependency injection within those feature modules. So yeah, activities, easy, just like this. You do the class name, start, activity starts. Okay, that's all you need. For fragments, well, again, you can use the fragment class still, but you know, you already see where this is going. Yeah, I'm using the activities and fragments are easy because underneath they use the reflection anyways, and they offer you the way to work with that reflection, so you don't have to bother really. Yeah, here with the fragment, you just put the fragment class, and you are able to instantiate something right after the module gets installed. Yeah. So anything else? Oops. Well, this is kind of something you would really not like to see during the code review. Yeah, really. That's the only way. Now the only thing you can do. Now the only thing you can do is actually try to find a workaround in how to do this. So you can try to reduce the pain, you can create an interface within the app module, create a delegating implementation of that interface within the app module, something like that. Yeah, so this is our app module, and then and that's kind of a proof of concept as I call it. That's the app module when you set your kind of a real instance somewhere here after the module gets initialized. Feedback that I provide. So this is the second conference I'm giving this talk to. I was giving this topic 2 weeks ago in the first Ukraine. There were lots of Googlers there. So I actually realized on the stage, looking on the code, how easier that would be if Google would introduce one small feature to those dynamic feature modules. That those dynamic feature modules have their own manifest, okay? You could define some kind of a sub-application within that manifest or some callback that would get called after this feature module is installed. So then after this feature module is installed, it could kind of reference the app things because it depends on the app. So it could reference the app classes and set its own instances to those wrappers and so on. Yeah, that would be much easier. Yeah, so it's a week and a half since I provided feedback to Google, and it's still not shipped on production. Przemek, I don't know. You guys need to work faster. So all this stuff is complex, yeah, and since there is no callback I was talking about, unless you are just working with the fragments and the experience of your dynamic feature modules starts with the activity, you will need to use class for name at some point. Yeah, if you really need to, for example, reference some class. Yeah, imagine you have the Instagram app, and there is this nice filter that only 1% of your users is using, so 100 million people, and this filter uses some native algorithm that is 15 megabytes. So you just want to download the class in order to call it. Yeah, you will be using class for name in that case. So the easy way, module center point being activity or a fragment. Yeah, so I will repeat it again, this document upload feature. Once user kind of needs it and you see that user needs it, you download the feature and you just start the activity, and that's the entry point. And that activity already, since it's defined within the dynamic feature module, it can reference all the classes you want from the dynamic feature module, so it works quite fine already. You don't have to use any reflection in there. So for the dependency injection, this works as well. So the use case being, you have some singletons within the app, I don't know, like a database or Yoke HTTP or whatever. You have them defined. We use Dagger. I think the problem will be similar for some other dependency injection or / IOC containers. Maybe even easier to solve than with Dagger. So you have this application component, and it exposes some singleton thermosiphon. You know what thermosiphon is? You haven't read Dagger documentation, right? Oh, okay, that's an internal joke. Lots of people complain about Dagger documentation because it uses kind of this thermosiphon stuff. So Dagger is complex on its own, and also the things that they are using as the examples is like ridiculously hard to understand, some hipster coffee stuff. No worries. And then within the dynamic feature module, you have this dynamic feature activity, and you want to inject some stuff. Yeah. So how I solve this? You have this component here, you mark it as a component dependency, you added scope, because in order to introduce some component dependency, this dependent component needs to have the scope as well. And then you do this, yeah? This is already happening within the dynamic feature module. So you use this Dagger generated builder, you pass the reference to the application component that you most likely keep within some application class, build, inject this, done. Okay, so we are able to access all those kind of singletons that you have defined within your base APK, within your dynamic feature modules. So, what is a good candidate for a dynamic feature module? Something that only portion of the users needs, and something that users won't likely need short time after installation. Don't extract the dynamic feature modules from things that are visible on the first activity, first screen that users will see. Yeah, imagine this thing. So you are about to board a plane, yeah, and you go somewhere and the flight will take 5 hours. So what do? Some people download Netflix. I watched everything that was already on Netflix, so I download some games. Yeah, I download them, one game, second game, third game. Yeah. Put my phone into the pocket, boarding the plane. Like a good citizen, I'm turning the airplane mode, and then I'm starting playing. Imagine that some developer came up with the idea, alright, this thingy, like the game engine, let's put it in dynamic feature module, yeah? I turn the game off and I cannot even play. So if users will need it in the short time after the installation, or the color functionality to the app, it should be included in the base APK. Don't make your users wait after they have already waited. So the document upload feature may be payments. Maybe users don't use payments on mobile because they, for example, don't trust the mobile devices or something. You need to answer based on your own data and how users are basically using your app. So some summary. Start using AppBundles. Dynamic delivery. You can start using them. It costs you nothing, and you benefit them, and your users benefit from them without any effort from your side. Just go to the Google documentation, copy paste some code into your build Gradle. It works, really. I mean, okay, you still need to configure the Google Play in case you are not using the Google Play app signing. But this is not a big effort. Dynamic feature modules, you might need them, but you might not. It might happen that your application, for example, is so condensed around one functionality that it doesn't really make sense to do all things dynamically. Yeah? I think most of the smaller apps will have like this. Do not overcomplicate. This tool might be something that you might not need. And if you actually feel that you need them, but you are in doubt because you are scared about amount of the effort that you will need to invest in order to make it, don't. I mean, just a matter of extracting one functionality after the other, after that the other functionality, one at a time. You don't have to rewrite the entire app in order to start benefiting from them. If you see some distinct features that your users probably will not need, but you want to download them dynamically, start with this one. Start with the one thing. Identify the biggest bit. That's like this. That will be suitable for this. And move it up. And don't treat it like the ultimate way of modularizing your app. Just because Google came up with this solution and this structure to provide the support for the dynamic feature modules, it doesn't mean that this is the ultimate way of how you should modularize your app in general. Okay, so remember what I said. The purpose of this is to keep your APK size smaller. And since the way it works, the features are loaded dynamically and the then classes are loaded dynamically, it needs to be this way that they're on the top of your APK. And it needs to be this way that the base APK doesn't know about it. Okay? But if, for example, you are not using the dynamic features modules because you don't need them, then most likely you can come up with much better modular architecture than this. Because the purpose of this is just to enable your users to have a smaller download size. Alright, that was it I had today. So I wonder if you have any questions.
1, 2, 3. So thank you for presentation. And I have case in my app that you have users, let's say, normally, and you have productions users. And is this solution is good for that kind of things, or it's better to just make a separate targets like it's usually I did?
I'm not sure if I understand the difference between the normal users and the production users.
Okay, so production users has more functionalities than normal users. For example, normal users can just only scan the QR, but production user can only scan the QR and, for example, have a map, Google Maps or something like this.
Okay, yeah. Yeah, that can make sense. If you can actually connect it somehow with the in-app payments and so on, if you use them or do whatever like this.
And so, the case is that the manufacturer user will only use the tablets, but normal users will usually use mobile phones.
Yeah, so this makes sense. I mean, I don't know your case specifically, but it looks like something that you should investigate whether that can be a good case. It sounds like it can be a good case. So what I would do in your place, I would see how much of the download side initially I will save in case I will move the stuff out to the dynamic feature module. Because if
if it's just the same functionality, but for example, you just have one more function, and the download side is going to be impacted by like 50 kilobytes, then don't bother. Yeah, you will do the effort for not really big benefit. But since you are saying that there are some maps or something, okay, maps are connecting to Google Maps anyways that are on the phone. So, well, you need to measure how much size you will really save on this. But it sounds like a proper use case. Yeah. So let's say you have a paid users and free users. Paid users have an access to functionality that is pretty heavy. Then yeah. And for example, there are only 2% of your app, then maybe it makes sense, depending on the size of the feature.
Okay, thank you.
We'll get there.
Thanks. Hello, thank you for speaking. I have a question about uninstall dynamic feature module. Can we download it once and then in some way uninstall it to reduce upside?
Yeah, good question. Didn't say anything about that. But the same API, the same library that you are using to install the things, you can use it to uninstall the things. Yeah, so the example with the document upload. Once the document is uploaded, it's like probably they will not need to upload it again. So it makes sense to uninstall this. Be a good citizen on the user's device and just uninstall this dynamic feature module. It's just a single call, and this happens asynchronously. So.
Thanks for the presentation. I have the question, in your financial app, do you use the instant features or the optional features that are downloaded that you mentioned?
The dynamic feature,
my
manager wouldn't agree on doing something within the beta stuff.
Okay.
Plus, you would need to ask Google in order to receive a permission to do this. So what I've been doing, so this is all just my ramblings, yeah?
Okay.
I don't have production experience on this, and you shouldn't have at this stage production experience with this either. I took our app, I started to extract some features, see if they worked. Just have some feelings.
Okay, and follow up. From my experience from the base core module, it's like 90% of your reference, or like the most heavy libraries are in there, like the run for the database, maybe Dagger for the dependency injection is in the base module, and basically my code is really relatively small to the base module dependencies. And how do you deal with this? Because like my modules are really small to comparing to the base module references, and it's like 90% of the size.
We're talking canonic?
Talking anything.
Okay. Yeah, I wouldn't bother probably. I mean, we need to measure the size. But so we have a couple of the examples when the feature that we would actually like to extract is already pretty heavy, but you're right that this base module is the biggest one anyways. Yeah, it has the support lib, it has all the dependencies that your application needs anyways. So it's pretty heavy. We had a couple of individuals. This is a huge app, and I only identified like 3 or 4 things that we could move and save another 6 megs, which would be like which would be actually a pretty nice result. But for smaller apps, I wouldn't say it's worth the effort.
Maybe last question.
Okay. Cool. Thanks everyone.